In this video, we are going to cover the concept of algebraic fraction. So let's get started with the basics. To understand an algebraic fraction, we need to first of all understand what a fraction is. What is a fraction? A fraction is simply any number written in the form x over y, where y is not equal to 0. What does this mean? It means anytime you have a number written in the form where there is a number at the top and another number at the bottom separated by a factor of division, then you have a fraction. As far as the number at the bottom is not equal to 0, that is a fraction. Now, a fraction is made up of two parts. The first part is the upper part, which we refer to as the numerator. So if I have a given fraction, this part is called the numerator, while the lower part is called the denominator. Examples of fractions include 3 over 4, 5 over 6, 7 over 8, 1 over 2, the list goes on. To recognize a fraction, it always has two numbers, one at the top and one at the bottom. Always remember that the one at the top is called the numerator, while the one at the bottom is called the denominator. So that's all we're going to take for now on fractions. Do want to check over my videos on fractions to understand everything about fractions. So let's go down with the order of the day. Like I said, in this video, we're going to be covering the concept of algebraic fraction. Now, what is an algebraic fraction? Have you know what a fraction is? What is an algebraic fraction? To define an algebraic fraction, we need to understand what an algebra is. An algebra is simply the branch of mathematics that allows the use of variables. The branch of mathematics that allows the use of variables is called algebra. What is variables? Variables are simply alphabets. Alphabets. Your A, B, C, D to Z are what we refer to as algebra. We refer to as variables in mathematics. Anytime you come across A, B, C, or D, or any letter being used in a mathematical expression, then we call that letters variables. And it is a branch of mathematics called algebra that allows the use of such alphabets in mathematical expressions. So having understood what an algebra is, we can go ahead with the definition of algebraic fraction. So now, what is an algebraic fraction? An algebraic fraction is simply any number written in the form of x over y, where y is not equal to 0, which contains variables. Or you simply put it as an algebraic fraction is simply any fraction that contains alphabets. Any fraction can be 1 over 2 or 3 over 4 or 5 over 6, etc. Once these fractions contains alphabets, either at the top or at the bottom, we call it algebraic fractions. Now, the example I have here is not an algebraic fraction because there is no variable here. There is no alphabet here. But once I attach alphabets such as 1 over 2a, or 3x over 4, or 5 over 6y, these becomes an algebraic fractions. So, in general, to identify an algebraic fraction, first of all, the expression must be in form of a fraction. And then secondly, this fraction must contain alphabets in it. And once you spot a fraction with alphabet, then you have an algebraic fraction. Examples of algebraic fraction include, like we have 1 over 2ax, 3y over 10z, 4xy over 2y, 8ab over c. As far as it contains alphabet, we don't care about the number of alphabet it contains, but once there is presence of alphabet in a given fraction, then what you have is called an algebraic fraction. Next, let's take a look at some arithmetic operations such as addition, subtraction, multiplication, and division involving algebraic fractions. But before we talk about that, let's start off with the variables. Variables. As we know, variables are simply alphabets. So once you see a variable in mathematics, a mathematical expression, just know that variables are simply what? Alphabet. Examples of variables include x, y, a, b, c, d, etc. Just call it anything as far as it's one of the letters put out from the ABCD that you know, then it is called a variable in algebra. Now let's kick off with some arithmetic operations of variables. So let's start with addition operation. Now what are the do's and the don'ts involved in adding variables together? Rule number 1, we don't add different variables. That is to say, only similar variables are added or subtracted as the case may be. So that's the first rule. We don't add different variables. Only similar variables are added or subtracted as the case may be. So what do I mean by this? So let's give some list of variables. We have x, y, z, a, b, and c. The list continues. So let's say we want to add variables together and we decide to add x plus a. The rule says these cannot be added together. As a matter of fact, x plus a is still x plus a. We cannot add it all together and say that x plus a has now become xa. This is wrong. Variables of the same values can only be added. Variables of different values cannot be added or subtracted as the case may be. But if we have something like x plus x, now both are similar variables. They can be added. It's just like when you're saying x is a variable. Let's say we have x plus x is the same thing as saying 1 bottle plus 1 bottle. How many bottles do I have? I probably have 2 bottles. So when you have x plus x, you're going to have 2x. So feel free to tell me what you have when you have y plus y plus y. How many y do you have? Probably have 3y. What about z plus z plus z plus z plus z? How many z do you have? You can just go ahead and count. 1 z, 1, 2, 3, 4, 5. Probably have 5 z. In similar manner, when you have 2x, it simply means x plus x. When you have 5x, it simply means x plus x plus x plus x plus x 5 times. If you have 3y, it probably means y plus y plus y. That's 3y. So, and that's it. So, how do we add these variables? Let's say we have 3a plus 4a plus 5a. What is the answer? Notice that we have 3a means a added 3 times. 4a means a added 4 times. 5a means a added 5 times. So how many a's do we have in total? So we simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have a total of 12a, and that is how to add similar variables together. So when you have 3a plus 4a plus 5a, you simply add the numbers. 3 plus 4 is 7, 7 plus 5, and that will give you what? 12a. And that's it. So feel free to pause the video and tell me what this is. Add 7y plus 3y plus y plus 2y. What's the answer? Feel free to pause the video and evaluate that. Of course, you got it. It's simply 7 plus 3, and that is 10. 10 plus 1y, that is 11. 11 plus 2y, and that is a total of 13y. Notice that we are only adding similar variables together. As a matter of fact, we cannot add different variables together, as the case may be. So let's move over to subtraction operation. The same thing applies in subtraction. Only similar variables can be subtracted. Unsimilar variables are better left alone. Example, let's say we have 3y minus y. What do we have? Just like saying 3 bottles minus a bottle. If you have 3 bottles and you remove 1 bottle from it, how many bottles do you have left? You probably have 2 bottles left. So in subtraction, you simply subtract variables based on the value that you have there. So when you have 3y minus y, you simply have 3y minus y is something as 2y. So feel free to tell me what 5y minus 2y will be. 5y minus 2y is something as 5 minus 2, and that is what? 3y. So these are the process of addition and subtraction operation with variables. So let's talk about multiplications of variables. In multiplication operation, what we simply do is we simply multiply a given variable the number of times it appears. Now, just like in the case of addition and subtraction, we say that in addition and subtraction, only similar variables are added and only similar variables can be subtracted. But in the case of multiplication, both similar variables and unsimilar variables can be multiplied together. And when that happens, you have the result. So let's say we have x multiplied by another x. That is similar variables multiplied together. When you are multiplying similar variables, what you are simply doing is you are counting the number of times these variables are multiplied. So you see x times x is the same thing as saying, since we have, just like in the case of addition operation, if I have x plus x, we say it is what? 2x. But if I have x multiplied by x, we say that it becomes x multiplied 2 times. That is x squared. Now, in similar manner, if you have y plus y plus y plus y plus y, we say it is what? 1, 2, 3, 4, 5. We say it is 5y. Now, when you have y multiplied by y, multiplied by y, multiplied by y, multiplied by y, what do we have? We have that this becomes y multiplied how many times? 1, 2, 3, 4, 5, raised to the power of what? 5. So just like we did in the case of addition, whereby the given number of variables are being written behind the variable itself. In the case of multiplication, the number of variables being multiplied are written as the power of the given variable. So let's take more example. So let's say we have x squared multiplied by x cubed. How do we take care of this? Now notice that x squared is the same thing as x multiplied 2 times, and x cubed is the same thing as x multiplied 3 times. So when we have x squared multiplied by x cubed, it simply means x multiplied 2 times multiplied by x multiplied 3 times. So how many x do we have here? We simply have this is for x cubed and this is for x squared. So how many x do we have? We have 1, 2, 3, 4, 5. Simply means x multiplied 5 times. So notice that we could have just added the two numbers to get our answer. So we have x raised to the power of 2 multiplied by x cubed is going to be x raised to the power of 2 plus 3, and that is x raised to the power of what? 5. Now this is the addition law of indices. So let's continue. So feel free to pause the video and tell me what y to the 5th power multiplied by y to the 4th power multiplied by y to the 2nd power will be. Notice that y raised to the power of 5 is the same thing as y times y times y times y times y 5 times. Multiply y to the 4th power is something as y multiplied 4 times. And y squared means y multiplied 2 times. And when this happens, you can see that how many y do we have in total? We have that this becomes y raised to the power of how many? So let's count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 raised to the power of 11. And that's the answer, which is in similar manner could have just been gotten by simply adding the variables, adding the powers of the variables. 5 plus 4, and that is 9, plus 2, and that is 11. So you have y raised to the power of 11. So in this case, we have seen a pattern here. And what is the pattern? Anytime you are multiplying similar variables, simply add the powers and you have your answer. So if I'm multiplying a similar variable, let's say b to the power of 3 multiplied by b to the power of 2, it simply means it's equal to b raised to the power of how many? Raised to the power of 3 plus, what's the power of b? This is to the power of 1 plus 2, and that is the b equal to 3 plus 1, that is 4 plus 2, and that is 6, which could have just been obtained by simply expanding this to be b multiplied 3 times and b multiplied 1 time and b multiplied 2 times, and that will give us a total of b multiplied how many times? 1, 2, 3, 4, 5, 6 times. That is how to deal with multiplication operation involving similar variables together. Now, what about multiplication operation involving different variables? Let's say we have x multiplied by y. What will be the answer? When x multiplies y, the answer is simply xy. So a multiplied by b multiplied by c simply means abc. When you have 6 multiplied by x multiplied by y, it simply means 6xy. In similar manner, when you have 8a squared b is something as 8 multiplied by a squared multiplied by b. Notice that a squared is the same thing as a multiplied 2 times. So this can be further expanded as 8 multiplied by a multiplied by a multiplied by b, as the case may be. Now, that is it for multiplying different variables. So in multiplying different variables, all you're required to do is just write down the two variables. And if two variables you're multiplying, you write it down like that. So now, what about division of variables? How do we divide variables? Now, to talk about the division operation with variables, it is important that anytime you are dividing a variable, a given variable with another variable, notice that only similar variables can be divided, just like we did in the case of addition and subtraction. Only similar variables can be divided. Different variables are better left alone. So if I have x divided by y, we just leave it like that. We cannot divide it. That becomes the answer. If I have b divided by a, and that's the answer. But if I have a squared divided by a, notice that a and a are similar variables. They can divide. Now, to divide similar variables, the best way to go about it is to, first of all, break the given variables into its simplest form, and then you can see what we cancel as the case may be. So let's say we have a to the third power divided by a. How do we do this? So we break it down to its simplest form. A cubed means a multiplied 3 times. A here simply means a once. So what it means is that a to the a cubed divided by a will simply have it that a can cancel one of a, and you have left with how many a? A multiplied 2 times. That will give you a squared. So what if we have x multiplied for x fourth divided by x squared? What will be the answer? So similar manner, we simply expand this. X to the fourth power means x multiplied 4 times. And x to the second power simply means x multiplied 2 times. So in this case, you can see what will cancel out. X can cancel x, and x can cancel x. What do we have left? We have 2x, 2 multiples of x left. So the answer becomes x raised to the power of what? 2. And that is how to divide similar variables. Remember, different variables cannot be divided. So if I have 2ab divided by c, this is just the answer. We cannot do anything here. But once we have different variables, then it is important that we break the variables down. So let's say we have a combination of two variables. Let's say, what do we do? So let's say we have a to the 6th power multiplied by b, that is, you have a to the 6th power b divided by a to the 2nd power. How do you simplify this operation? How do you divide? Now, to divide this operation, you have to reduce the given variable to its lowest term. So to reduce the given variable, what we simply do is that you have to remember that a to the 6th power b is the same thing as a to the 6th power multiplied by b. And a to the 6th power means a multiplied by a multiplied by a multiplied by a. That is a multiplied 6 times. So if we implement that strategy here, we can see that a to the 6th power multiplied by b means a multiplied 6 times multiplied by b, and everything will be divided by a squared means a multiplied 2 times. Now, the essence of expanding this is to see the numbers to cancel and to divide. So in that sense, we can see that 2a here can take care of 2a here. So how many a do we have left? We have a 1, 2, 3, 4. So a to the power of 4 multiplied by what? B. And that's all that we have, which is something as a to the power of 4b. And that is the answer. So that is how to simplify a given fraction. Notice that we have actually entered the real thing behind algebraic fraction. This division operation with variables is actually the beginning of simplification of algebraic fraction. So let's take one more example before we enter algebraic fraction proper. So let's take one more example. So let's say we have 2x to the 7th power multiplied by b to the 2nd power divided by xb. Feel free to pause the video and divide our operation. Remember, only similar variables can be divided. So in that case, the first step is reduce the variable to its simplest form, and then you go ahead with the division. So let's break the variables down to its simplest form. To break this down, we have 2x7b squared is the same thing as divided by ab divided by xb is the same thing as 2 multiplied by x to the 7th power multiplied by b to the 2nd power divided by xb. So that's what we have there. So in that sense, we'll go ahead and simplify further. In this case, we have that this will become 2 multiplied by x to the 7th power means x multiplied 7 times. You have x times x times x times x, 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 and x. That is 7 times. Now b squared means b multiplied 2 times. That is multiplied by b times b. Everything here is divided by x multiplied by b. So like I said, only similar variables can be divided. So what we have here is x and b. So x will take care of one of the x and b will take care of one of the b's. So what do we have? We simply have 2 multiplied by how many x do we have here? X is 1, 2, 3, 4, 5, 6. We have 6x, and that is x to the power of 6 multiplied by only one b is left, and that is there. So we go ahead and break this down. 2 times x to the 6th power times b is something as 2x6b, and that is the answer.